In 1965, two men in New Jersey found a noise in a horn antenna that would not go away. It was not pigeons, it was not electronics, and it was not weather. It was the cooled afterglow of creation itself, now only 2.7 degrees above absolute zero. Then in 1998, exploding stars told us the universe was not merely expanding, it was speeding up. And after all that, after the radiation, the galaxies, the equations, and the Nobel Prizes, we still miss the most brutal fact. The end of the universe is probably not an ending at all. That is the part I got wrong. Not because I thought the universe would end tomorrow. I was never in the business of selling panic. I wrote about billions of years, trillions of years, dead stars, exhausted suns, proton decay, entropy, the gradual thinning of useful energy until intelligence itself becomes a thermodynamic luxury. I like the long view. A man who writes foundation does not frighten easily at large numbers. But I carried, and many intelligent people still carry, one wrong picture, that the universe has a final scene, a last fire, a last collapse, a last cold darkness into which everything together declines. That picture is tidy. It lets you imagine the universe as a machine that winds down in one room. It lets you believe there will be, somewhere, somehow, a final state of all things. It is educated nonsense. The gear that breaks is expansion. Most people hear the universe is expanding and imagine galaxies flying outward through pre-existing space, like fragments from an explosion. That is already wrong. But it is not the fatal error. The fatal error is thinking that expansion merely separates things. It does more than separate things. If the acceleration continues, it removes things from causal contact. It does not just make galaxies far away. It makes them unreachable, then unobservable, then irrelevant to any future physics done inside our remaining patch of reality. That is a different kind of end. It is not death, it is amputation. Let me put the first block down carefully. In the early 20th century, Einstein's equations allowed a universe that changed. Einstein disliked that. He inserted the cosmological constant to keep the universe static. Then galaxies showed redshifts, and Hubble's work made the static universe look like a bad habit. The first correction was the universe expands. The second correction was gravity should slow the expansion. The third correction, the one that arrived after I had done my writing and my arguing and my dying, was the expansion is accelerating. The 1,998 supernova observations found distant Type Ia supernovae dimmer than expected, corresponding to distances about 10 to 15% farther than a low-density universe without a cosmological constant would predict. That is not a poetic difference. That is a ruler thrown across billions of light years and coming back with the wrong answer. Here is the first unpleasant consequence, and I want you to hold it because I will return to it. The universe does not need to destroy a galaxy in order to erase it from your future. It only needs to expand space fast enough between you and that galaxy that no signal sent later can ever reach you. The galaxy remains real. It shines for its own inhabitants. It has chemistry, history, perhaps arguments, perhaps fools. But for you, it has been cut out of possible evidence. That is worse than a dramatic apocalypse, because it is quieter and more absolute. When I was a boy in Brooklyn, my family had candy stores. I have no intention of making that sound romantic. Candy stores are work. You stand, you sell, you sweep, you keep accounts, and if you are a child with a greedy mind, you read the magazines on the racks before they are sold. Those magazines were my first expanding universe. Every cover promised Mars, robots, ray guns, impossible cities. I learned early that imagination is cheap unless it is disciplined by mechanism. The candy store taught me a sentence no professor ever improved. What exactly makes the thing happen? That question is why the common picture of the universe's end fails. Everything gets cold is not a mechanism. Everything fades is not a mechanism. The mechanism is that usable energy gradients disappear, while acceleration divides the universe into patches that cannot exchange information. The future is not one cold warehouse. It is a set of locked rooms, each losing its light separately. Now close the loop I opened. How can something remain real and still vanish from the universe you can study? Because astronomy is not possession. Astronomy is receipt of information. A galaxy 10 billion light years away is not an object you have in hand. It is an event sending photons into your telescope. If future photons can no longer get here, then that part of reality has left your scientific world, even if it has not left existence. And that gives us the next problem, the one educated people resist most. The observable universe is not the universe. It is only the portion from which light has had time and will have opportunity to reach us. The universe is about 13.8 billion years old under the standard model measured by Planck. That number tempts people into a child's conclusion. If light has traveled for 13.8 billion years, the visible universe must have a radius of 13.8 billion light years. Wrong. Space expanded while the light traveled. The observable universe is roughly 46 billion light years in radius today. That is the sort of number that should make you stop speaking for a moment. The oldest light did not cross a static room. The room stretched while the light was in flight. This is where the wrong idea mutates. People say, fine, the universe is bigger than we see, but given enough time, surely we will see more. That sounds reasonable. It is false in the accelerating universe. There is a horizon not merely behind us, but ahead of us, a boundary beyond which events that happen now can never affect us, no matter how long we wait. The machine breaks again at the same gear, expansion. If expansion were slowing forever, waiting would be a form of power. The future would reveal more. But if dark energy behaves like a cosmological constant, waiting eventually reveals less in the only sense that matters. Distant galaxies cross out of causal availability. Their old light may continue to arrive for a time, stretched, reddened, weakened, but new information from them is lost. The universe becomes observationally poorer with age. The present inventory is already insulting to human intuition. NASA gives the rough composition plainly, about 5% normal matter, 27% dark matter, and 68% dark energy. The stuff that made your blood, your books, your telescopes, your self-importance, all of it belongs to the 5% minority. Now, do not make the lazy mistake. Do not say dark energy is a mysterious force pushing galaxies apart. That is the cartoon. A force pushes objects through space. The better description, though still incomplete, is that space itself has an energy density associated with it, and in general relativity, pressure gravitates. Dark energy has negative pressure. That negative pressure changes the expansion dynamics. The result is not a wind blowing galaxies away. It is the metric of distance itself changing in such a way that sufficiently distant separations grow faster than light could bridge them. No law of relativity is broken. Nothing locally outruns a light beam passing beside it, but two remote galaxies can have more space inserted between them so rapidly that a light signal from one never reaches the other. Relativity forbids motion through local space faster than light. It does not forbid the scale of space from changing. There. That closes the second loop. The correct picture is stranger than the wrong one because it does not require a cosmic explosion or a cosmic wall. It requires only that the universe obey its geometry. I trained as a biochemist, and that matters more than you might think. Biochemistry is the discipline of not being impressed by names. A protein name is not an explanation. A vitamin name is not an explanation. A pathway diagram with arrows is not an explanation unless you know why the reaction proceeds, what energy pays for it, what enzyme lowers the barrier, what concentration gradient is being spent. At Boston University, where I taught biochemistry, a student could memorize the citric acid cycle and still understand nothing if he did not know why carbon moves step by step toward lower free energy. The universe has its own metabolism. Stars are its enzymes. Gravity gathers hydrogen, pressure and temperature ignite fusion, fusion builds heavier elements, supernovae distribute them, planets form, chemistry complicates, and sometimes chemistry writes essays. But that metabolism depends on gradients. Hot next to cold, dense next to thin, bound next to unbound. The end of useful cosmic history is the end of exploitable differences. This is where people think they understand heat death. They say everything becomes the same temperature. Good, but too crude. The deeper point is not temperature alone. It is the loss of free energy. A universe can contain energy and still be dead to work. The sea contains enormous heat energy, but a ship does not move merely because the ocean is warm. It moves when there is a difference that can be used. The wrong idea says the end comes when everything runs out of energy. No, energy is conserved. The end comes when energy becomes useless. Now, I am going to give you a number that should offend your sense of scale. A red dwarf star may burn for trillions of years, not millions, not billions, trillions, long after every star like the sun has swollen, shed its outer layers, and left a white dwarf cooling like an ember. The smallest stars will still be spending hydrogen with miserly efficiency. If the universe were a bank account, red dwarfs would be misers who die rich. That matters because it destroys the theatrical ending again. The stars do not all go out. They go out on wildly different schedules. The universe's end is not synchronized. It is not a curtain falling. It is lights failing in rooms so far apart that the rooms can no longer know the others exist. And the long-lived stars are only the early chapter. After star formation ceases, after gas is locked up or expelled, after galaxies dim, remnants remain, white dwarfs, neutron stars, black holes, planets frozen beyond biology, and perhaps particles themselves waiting on laws we have not yet confirmed. If protons decay, ordinary matter has another clock. If they do not, matter has a different future. Either way, the old human hunger for a single final moment is childish. Here is the next loop. Black holes, which look like the most permanent objects in the universe, may become the last candles. And they die not by exploding in the ordinary sense, but by obeying the smallest leak in quantum theory. Before we close that, I want to say why I once loved cleaner endings. When I argued with John W. Campbell at Astounding Science Fiction, and believe me, Campbell could argue with a wall and expect the wall to improve. The issue was rarely whether an idea was big enough. The issue was whether it had internal rules. Foundation was not about predicting the future, because I thought history was a railway timetable. It was about whether masses of human behavior might have statistical structure, the way gases have pressure, though no single molecule knows the law. The appeal was not prophecy. The appeal was order. That is the temptation in cosmology, too. We want the end of the universe to be orderly in the literary sense. Big Bang at the beginning, heat death at the end, humanity somewhere in the middle writing nervous footnotes, but reality has no obligation to supply narrative symmetry. The beginning may have been hot, dense, and communal. The end may be cold, thin, and private. Now, black holes. Classically, a black hole is a one-way surface in space-time. Cross the event horizon, and all future-directed paths lead inward. It sounds final, but quantum field theory near a horizon produces Hawking radiation. A black hole has a temperature. A small one is hotter. A large one is colder. A stellar mass black hole is absurdly cold, far colder than today's cosmic microwave background, so it does not yet evaporate in any practical sense. But when the universe cools further and further, black holes become net radiators. They lose mass very slowly. Then faster near the end, a supermassive black hole can take something like 10 to the 100 years to evaporate. I want you to hear that, not as a number, but as an insult. Write a 1, then 100 zeros. Now remember that the age of the universe is only about 1.38 times 10 to the 10 years. We are not close to the last act. We are not close to the lobby of the theater. That closes the black hole loop. The darkest objects are not eternal monuments. They are delayed thermodynamic events. The universe keeps receipts longer than the human mind enjoys. But even this picture has a flaw, and it is my flaw as much as anyone's. It still imagines that if we wait long enough, physics gives us a complete accounting. It may not. Somewhere between the comfortable heat-death story and the accelerating horizon story is a disturbing fact. Future scientists, if any exist in a galaxy group like ours, after all distant galaxies have disappeared beyond the horizon, may no longer have the evidence needed to infer the Big Bang. The cosmic microwave background will be redshifted to absurd wavelengths and diluted into practical invisibility. External galaxies will be gone from view. Local gravitationally bound systems will remain, but the grand evidence of expansion may be missing. Think about that carefully. The truth of the universe may become harder to discover with time. That sentence would have irritated the young man in the Brooklyn candy store. It irritates me now. I spent a life believing that ignorance retreats when intelligence advances. In local problems, often it does. In cosmic problems, the evidence itself has a lifespan. The archive burns slowly, and it burns by expansion. This is not science keeps asking questions. That is a harmless slogan. I am saying something sharper. A true theory may become empirically unrecoverable to observers born too late. Not because they are stupid, not because they lack instruments, because the universe has removed the records. That is the crack in my armor. I believe deeply in explanation as a permanent human victory. I still believe in explanation, but I no longer believe the universe is obliged to preserve the evidence for every explanation until minds arrive to request it. Carl Sagan understood this pressure better than most public scientists. He had the poet's reach, yes, but more important, he had the astronomer's discipline. He knew that a photograph of Earth from far away was not sentiment, it was data with moral consequences. I did not always share his tone. I was more bricklayer than cathedral window. But we agreed on the essential matter. Science is not a list of facts. It is a method for staying honest when reality refuses to flatter you, and dark energy refuses flattery. The most unsettling modern possibility is not simply that dark energy exists. It is that we do not yet know whether it is truly constant. The standard model, lambda cold dark matter, treats it as a cosmological constant, and that model remains remarkably successful. Planck's results found excellent consistency with the 6-parameter lambda CDM model. But newer surveys have pressed on the question of whether dark energy might evolve, and the debate is not decorative. If dark energy changes with time, the fate of the universe changes with it. If dark energy is constant, the future tends toward accelerated expansion, isolation, cooling, horizon-limited patches, black hole evaporation, and a near-empty de Sitter-like state. If it weakens enough, gravity might eventually regain authority. If it strengthens in the wrong way, a so-called big rip could tear apart galaxies, stars, planets, and eventually atoms. I do not offer that as the likely ending. I offer it as a warning against pretending we have already read the last page. Here is the next loop. The question is not merely how will the universe end? The deeper question is what kind of universe allows its own history to become unknowable? that is, the floor dropping away. My robot stories were built around laws. A robot may not injure a human being. A robot must obey orders unless that conflicts with the first law. A robot must protect itself unless that conflicts with the first two. Simple, clean, apparently complete. And then the stories begin. Because laws are not stories until they fail under pressure. Cosmology is similar. Conservation of energy, relativity, thermodynamics, quantum fields. Each law is elegant in isolation. But the universe is not obligated to make their combination emotionally satisfying. Expansion preserves local physics while destroying global access. Thermodynamics conserves energy while draining usefulness. Quantum theory gives black holes a temperature while making information a wound in the theory. General relativity makes horizons ordinary mathematical surfaces and, at the same time, walls around possible knowledge. The educated wrong idea says the universe is a complete object and the end is what happens to that object. The better picture says each observer has a horizon, each horizon edits reality, and the far future may consist not of one universe ending, but of many isolated patches losing the ability to compare notes. That is not mysticism. That is the mechanics of causality. Now close the loop. A universe that allows its history to become unknowable is a universe in which truth and evidence are not permanently married. That should bother you. It bothers me more than heat death. Heat death is merely the end of work. Evidence death is the end of reconstruction. It means that reality can have been one way, and yet no future intelligence can prove it from within its remaining sky. You may say, but the truth still exists. Yes. And what of it? A truth with no possible evidence is not science. It may be metaphysics, or memory, or divine bookkeeping, if you like that sort of thing, but it is not physics available to an observer. Science lives on contact. Break the contact, and the truth becomes sterile. This is why the phrase, the end of the universe, is too small. The terrifying object is not the end. It is the shrinking of the knowable. It is the conversion of astronomy into local archaeology. It is the future scientist staring into a black sky and building a perfectly rational, perfectly false model of an island universe, because the bridges burned before she was born. And now the old heat-death picture looks almost comforting. At least in that picture, everything dies together under one law in one shared arena. But accelerated expansion is less generous. It gives each island its own darkness. It does not kill reality. It partitions it. I said I got it wrong, so let me be exact. I was not wrong to take entropy seriously. I was not wrong to think stars are temporary, civilizations fragile, energy gradients precious, and human vanity ridiculous against geological time, let alone astronomical time. I was wrong in accepting too easily the image of a universal final condition, as though the universe were a closed laboratory flask. It is not a flask. It is expanding space-time with horizons, and horizons are not scenery. They are editing rules. When you grasp that, the old questions change shape. Will the universe end in fire or ice? Too crude. Will matter decay? Important, but incomplete. Will black holes evaporate? Necessary, but still not the heart. The heart is this. What remains of reality when no observer can assemble the whole story? The answer may be local facts, fading records, isolated remnants, and laws that still operate perfectly while explaining less and less of what once was visible. That is the most Asimovian horror I can imagine. Not monsters, not gods, not punishment, a rational universe in which reason arrives too late for the evidence. And do not comfort yourself by saying humanity will be gone long before then. That is probably true, but it is an evasion. The question was never merely whether our species survives. I spent much of my life writing about humanity because humanity was the tool at hand. The larger issue is whether mind, any mind, can keep pace with a universe that hides its own premises. We are early enough to see the microwave background, early enough to see galaxies beyond our local group, early enough to measure acceleration, early enough to know that normal matter is a 5% garnish on a dark energy-dominated universe. That timing is not our achievement, it is our luck. So when a smart person tells me the universe will end someday, I want to ask, which universe do you mean? The totality? The observable patch? The causal future? The record available to intelligence? The thermodynamic ability to do work? These are not the same question, and treating them as one is the original sin. The end of the universe is not a date on a cosmic calendar. It is the progressive failure of contact. The universe does not have to die to defeat us. It only has to become true in places no truth can reach.